next we are going to import a CSV dataset file and convert it into a graph and perform graph algorithms like triangle count, page rank algorithm, label propagation algorithm, BFS algorithm on the graph, and also find shortest path with respect to landmarks, and finally save the graphs to generate it to a file. Now let us look into the code. As we can see, first we loaded the file trip data CSV, which is of the format CSV and which has header the column names into trips underscore data frame, and station underscore data dot CSV, which is a format CSV and which has a header that is column names true loaded into station underscore data frame. Before looking into the code, let us look into the data set. Station underscore data CSV has the details about stations, about each station, the station name, the latitude, longitude, station ID, etc. And trip underscore data dot CSV has the data about trips with the trip data between the two stations, the start station and the end station. Now moving on to the code, when we want to create a graph, the stations over here would act like vertices and the trips between the stations would act like edges. We are just printing the schema of the trips underscore df and the stations underscore df. Now we would like to create a temporary view so that we can perform SQL queries on the trips underscore df and the station underscore df. The view created on the trips underscore df is named as trips, and the temporary view created on the stations underscore df is named as stations. In station, I'm storing all the data from the station. Select star from stations. And in the trips, I'm storing all the data from the trips. Select star from trips. Now, as we already discussed, the station would be acting like vertices. And when we are creating a graph using the graphics, we would want the column of the station with ID. So we are renaming the column name to ID, as this is required while creating the graph. And in the edges, we want to rename the column of start station as source and the end station as destination, because when we are creating a graph, edges are identified by source and destination. The vertices in the edges are identified by the source and destinations. Now we are directly creating a graph using the graph frame by giving the station vertices with ID and trip edges with source and destination. Now we are printing the total number of stations and total number of distinct stations and total number of trips in graph and the total number of distinct trips in graph. And the total number of trips in the original data is nothing but the trips dot count of this. Moving on to the later code, we are performing the triangle count on the station graph. Triangle count is nothing but we can rather tell it like more like a cycle where incoming and outgoing nodes or at a particular node, we would be counting the triangles at each vertex, and we are displaying the output of the triangle count. Moving on to the next algorithm, we are performing the shortest path. We are given a sequence of locations: Japantown and Santa Clara County Civic Center. So we want to find the shortest path between the sequence. We are using the station graph dot shortest paths, and we are giving the landmarks, and we are running, and we are displaying the output. The next algorithm is the PageRank algorithm. PageRank algorithm finds the importance of the node depending upon the adjacent nodes, depending upon the nodes with which it is connected to. Over here, I'm giving the reset probability as 0.15, which decides at randomly at the randomness at which a node can be selected to start the walk, and the tolerance as 0.01. This value determines in an iteration, if the change is less than 0.01, then the algorithm would terminate and give us the results. After performing the PageRank, I'm storing the result in station PageRank, and I'm displaying the vertices and the edges. I'm writing the output vertices to graphs vertices, and I'm writing the edges to the graphs edges. Then I'm performing the label propagation algorithm on the station graph. Label propagation algorithm divides the vertices into communities. It groups the vertices, and the maximum number of iterations I'm giving over here is as 5, and then I'm displaying the output. Then I'm performing the BFS algorithm on the station graph, and I'm given the from ID equal to Japantown and to ID doc count less than 15, and I'm running it, and I'm displaying the output. Let me run this program. As we can see, here is the output. This is the structure of the trips data frame, and this is the structure of the stations data frame, which is the trips is the edges and stations is the vertices. This is the total number of stations, distinct stations, trips and graph, distinct trips and graph, and trips and original data. Moving on, this is the data of the stations. This is the data of the trips. And after performing the triangle count of at each vertex, that is at each station, is displayed over here. After performing the shortest by giving a sequence, the shortest is given over here from Japantown to Santa Clara. We have performed page rank, and the page rank is displayed over here. For each station, the page rank is given, and this depends upon the weight of the edges, which is displayed over here. Since trips is the edges, weight is determined for the edges, and depending upon this, the page rank is given. And this is the label propagation. So for each station, a label is assigned. It is assigned to a community or a group, and we can see the labels over here. And this is the BFS, where bit doc less than 15. And this is the output of ICP6, and we can see that edges, it's written to the edges and the vertices. You can see that it's written over here, and it's written over here. So the vertices are written over here. This is all about the ICP.